Hi everyone, welcome. My name is Sean Devine and I am the rental coordinator for Global Test Supply. Today, we are going to be talking about facilities maintenance, realizing cost savings through proactive maintenance and energy savings with Fluke. We kindly ask that you mute your microphone for the duration of the webinar. Our presentation is going to last between 40 to 45 minutes, and then we're going to have some time at the end for a Q&A. So we encourage you to ask questions anytime. Simply use the chat feature and we'll get to your questions at the end during the Q&A period. Global Test Supply has been working closely with Fluke for many years. We pride ourselves on being a leading distributor of Fluke. This is a result of our dedication to offering you our product expertise, service, and competitive pricing. Okay, so let's get started. Today's webinar is presented by Dave Robley from Fluke. Dave has been with Fluke since 1984, recommending test equipment solutions for customer applications relating to thermal imaging, vibration testing, power quality, electrical measurement safety, and motor drive troubleshooting. Dave is a level 1 certification in infrared thermography and vibration analysis. He also holds a BSEE from Marquette University and currently works as a sales application manager based in the Chicago area. Dave, thank you so much for taking the time today, and it's all yours. Thank you.
Thanks, Sean. Appreciate it, and thanks everybody for having us in virtually today. As Sean mentioned, we're really going to be looking at cost savings and examining two different aspects and areas of cost savings. One with proactive maintenance, and then the other energy savings and a particular aspect of energy savings, namely leaks or detecting leaks in compressed air systems or other gases with a new technology called acoustic imaging. So I think we'll get started now, and we'll first we'll look at proactive maintenance. I'm not sure about the audience who's involved with maintenance, but I suspect that many of you are, and if you are, you know that it pays to be proactive when it comes to maintenance or maintenance strategies. So trying to head off downtime, head off failures, trying to schedule maintenance before the downtime schedules you. We'll quickly review just a few different areas in which it does pay to be proactive. You can look at the chart below. This is an example of rotating machinery, motors, pumps, compressors, etc., and the costs per horsepower to operate them or maintain them to based off of a reactive strategy, breakdown maintenance versus being predictive or trying to schedule maintenance out ahead of the breakdown. So significant savings there. Significant maintenance cost savings, certainly reductions in downtime, extending life of equipment, breakdowns. Let's try to equate this to something a little bit more real, in terms of dollars. The way that you could look at this is, let's say if you have a 100 motors averaging 50 horsepower in your facility. You can see that you can really affect some pretty significant maintenance savings, up to about $40,000 a year using some of the numbers down below. And again, because downtime could be at play, let's say if you have even 16 hours of downtime, if that's 10K an hour, then that downtime is costing you $160,000. If you can lower that 40%, that's well over $60,000 of downtime that can be eliminated. So as we go through this, try to keep thinking of the term cost avoidance. By being proactive, what costs can we avoid? Because that's very important when it comes to being able to help make potential investments in a proactive maintenance program. It's not without its challenges. Boy, the world of maintenance, it's difficult. There's a lot of challenges that you're facing. You're trying to do more with less. The assets are more complex, more critical than ever. And what you've also probably seen is that over time, a lot of people that have that tribal knowledge on site, that know equipment very well just by sound, touch, feel, they can tell if something is running right or not. Well, a lot of those people are leaving the workforce, retiring, and there are newer people that may be well trained, but they don't have that experience as to what good looks like, or to determine when an asset is healthy or not. So that's a challenge. Some customers that we talk to are, they spend a lot of time essentially spinning their wheels, doing the same work over and over and over. For example, bearings and pump seals. That's one that we hear about a lot. And boy, if you could get out ahead of that or find out what's causing that, it makes a lot of sense. If we want to get out ahead of that, what tools do we use? There's a lot of tools out there, a lot of technologies. Where do we start? What do we choose? And then being in maintenance, oftentimes you have to justify investments that are the right ones to make. But how do we justify the cost of those tools? So we're going to take a little bit deeper look at that as well. And then finally, how do we get started? I've heard stories of places that, yeah, we tried to put in a predictive maintenance program, but we never got it off the ground. It was just too much data, too difficult, too big. So we'll look at all of these and make some recommendations about considerations to approaches that might help in each of these 4 areas. We're going to look at the concept of tiered maintenance. So now I think your maintenance teams are in a position where you have to kind of make choices, none of which are good, as far as what to work on first. Probably the downtime is scheduling your time. You'd like to get out ahead of things. So we're going to recommend taking a look at an approach called tiered maintenance. Now, the medical industry has actually employed something along these lines for quite some time. So if you equate people, to being maybe an asset in a plant facility, the assets are all important. So, how do you use what resources have you had to kind of narrow down to really focus your efforts? And how a healthcare industry does it is by having different levels, or a tiered approach, where at the initial level, you have intelligent screening, trained nurses, nurse practitioners making intelligent health assessment measurements that may screen to find out everything is fine, or perhaps identify and correct at this level. If it's not a solvable problem at that level, diagnostics might be needed. And then in some cases, specialists. So kind of keep that in mind, that tiered approach. Use quick screening tests to determine if something is healthy or not. And if it's not, then take corrective action. Part of that corrective action might be a deeper dive or diagnosis. Why is this a problem? And there might be situations where there are specialists with advanced tools used only if needed. So carrying that over to the maintenance side now, it's kind of the same thing. We're kind of advising that same approach, screen assets. And then for assets that are maybe semi-critical to more critical or repetitive failures, take a diagnostic approach. But the thought here is that if you have many assets, 500 or more assets in a plant, if you could screen down from those 500 assets and find out the 25 or 30 that are bad actors or need the attention, there's a lot of value in that. Rather than having to try and maintain everything, screen everything, make health measurements, and then determine whether we need to go to a diagnostic or an analysis level. So rather than analyzing healthy machines, screen everything, determine what's healthy and what's not, and try to make the most of your potentially limited maintenance resources on site. So we'll keep referring back to that tiered approach: screening, diagnosing, and then you may need to refer complex problems on maybe complex machines to experts. This graphic just shows this applied in a little bit more detail to types of machines. So one of the things here is you want to, again, employ a screening approach, and then as assets are more critical or they have more impact from a downtime standpoint, because it's not just size of the asset or horsepower in the case of motors, it's how critical is that if that asset goes down. So one of the things that we'll recommend also is that people perform a criticality survey. Take a look at all of your assets and then determine where do they fall in terms of a lower or mid-range importance or mission critical. And then once you have that, kind of match the right approach, screening, diagnostics, analysis, to the asset. And as we get a little bit further into the presentation, we'll also be looking at what are the different types of tools and technologies that might apply, and how do you match those to the appropriate skill level. Another thing that you can use is on-site knowledge on how these assets, what's a typical failure mode? So part of that criticality survey is to identify failure modes. The example of that I used before for we keep fixing the same problems over and over. We see that a lot with bearings and seals on pumps, rotating equipment. Well, maybe the situation is you have an underlying root cause that you're not aware of, and about 50% of the issues, the damage to bearings and seals, premature damage, is really caused by a condition of misalignment. So all the forces are still there, even if you have flexible couplings, all the forces are still there from misalignment, and they're transmitted to the bearings and the seals. So if that's something that's happening, it's a failure mode on a number of your assets, you might want to consider an approach to move towards a diagnostic approach. Don't just repair bearings and seals, find out what's causing that. And in this case, you can see that there are misalignment issues present. So more diagnostic approach will tell you not only do you have bearing issues, but you have an underlying fault, namely misalignment. And then of course, if alignment, you don't have a formal alignment program, that might be something to consider on site with coupled machines to make it very quick, very easy, if that is a failure mode and a root cause, to take corrective action. So let's take a quick look on some of the tools that we might be able to use. But again, start with a screening approach. There's a number of handheld tools that can be used for screening. We'll examine each of the different types in a little bit more detail. But infrared, thermal, or heat can tell us a lot about assets. A variety of electrical measurements, vibration measurements, power, insulation resistance testing, those can all be used to assess health. And then that health data can be stored or logged wirelessly to a mobile device via the Fluke Connect app, and then even trended or looked at over time as it merits it. So for example, let's say through vibration screening, you find you have excess vibration and bearing issues. If the asset's important enough, it might be worthwhile to do a deeper dive and then find out that, we have a misalignment condition. So that is causing our asset to be unhealthy. Well, then you can actually take corrective action to that to prevent that from happening again. So that would be showing a corrective action to the problem. And then once everything has been corrected, remeasure, check to make sure everything is looking good. Let's take a look at some of the things to consider as far as being successful in a predictive maintenance program. The number one killer of predictive maintenance programs that I've seen and customers have said is that they're too big. How do you get started? They're just so far reaching. So what we're recommending is start small and then grow, okay? Pick some assets, determine again, failure modes, that criticality survey, what type of technology and tools would best be used to determine health. Start there. Demonstrate or find cases of mitigating downtime, and then show, well, what was the cost avoidance of this downtime event? That will help provide funding for growing your program over time. Next, technology section. What type of measurements, electrical, thermal, vibration, are best to match likely failure modes, or from your experience, what the failure modes are. It's not a one tool, one technology fits all. Different tools for different types of sections. So determine the types of tools that can make intelligent health measurements that will be able to best head off issues. And then finally, data. That's part of the reason why a lot of programs never get off the ground if they start out too big. They require massive amounts of data. Well, if you start small and you're making a few simple health measurements, you can see some results pretty quickly. And that could be as simple as seeing readouts on the tools themselves. You can take action. It could be in the Fluke Connect app, perhaps an asset health dashboard picture of what's going on. Or even if you do have a enterprise level maintenance management system, it could be that. But rather than having data for data's sake, answers, actionable answers as far as what to do from the data. So now we'll take a look at getting into the different types of technologies itself. I think a lot of us have seen this life cycle or potential failure curve on assets. And as assets age, they're in the process of failing. So really what you would like to do at some of those different dots along the way there are make some health measurements to assess what's healthy, what's not. Let's take corrective action, kind of back up in here before here. And there's benefits, both from an energy standpoint as well as a cost or repair standpoint of catching things earlier. We're going to be looking at three areas in particular: infrared or thermography, electrical, and also vibration. But each of those technologies can offer either basic or advanced information, depending on the user. And also they can tell you a little bit, just as with healthcare screening, different types of measurements tell you different things, but they're all related to health. So you might need a different mix of technologies depending on the assets. So now let's take a look a little bit deeper at some of the types of technologies and tools associated with that. Thermal imaging, thermography, that's something I think a lot of people are familiar with at this point. You may even have them infrared cameras on site. They essentially see pictures of heat or infrared energy. That's what we feel. So they pick up surface temperature off of a wide variety of assets, and that information can be used to determine health or lack of health. It's pretty easy to use cameras, very easy to take pictures, take good focused images, but it might take some experience, both with interpreting images, but also on-site experience to know, well, what could be causing what I'm seeing here in the image. So there's a number of environmental variables that you need to consider. It's helpful to know some of the basics of thermography. We found that programs do better if they have somebody that is a champion, and it's helpful perhaps to trend over time or get baselines. We'll come back to that as far as some different approaches to implementing infrared on site. Wide variety of applications. Electrical problems are probably the most commonly known for infrared. If you have any kind of a background in electrical systems, you know what generates heat. You can use that knowledge and apply that to the image to tell you what could be going on. So things like unbalanced loads, or maybe hot connections. Here's a nice example of single phase condition, for example. You can look at that, and that can actually be a diagnostic image for you to tell you really what is wrong, so we know how to take corrective action. For mechanical, might not be quite as straightforward, but still images can tell you a lot. We'll look at some different ways, again, that especially for mechanical, that you can actually use some techniques to be able to determine what's healthy or what's not, or what needs more attention. But you can still see a lot of different types of issues, as with roller bearings there. You can see, well, this one looks like it's at ambient temperature. These two are hot, fairly definitive. You can see this pillow block bearing here is quite hot, as opposed to that side. Or again, you can see this coupling and bearing. You don't know, what's a good temperature or bad temperature for a bearing. Well, we don't know. So let's take a look at some types of approaches that you could use. But thermal imaging, fast, non-contact, works very quickly. It makes a great screening tool in a lot of situations. Here's a couple of different, actually 3 different approaches that you could use on site. One is certainly if something or a piece of equipment's brand new, you can baseline it or capture images that you can use for trending purposes down the line. Even if your equipment's not new, you have to start somewhere. You can take an image and see, well, what does it look like today? Thermography, it's the science of temperature measurements. Those measurements are turned into an image. So you have access to the numbers. So if you wanted to, you could measure that bearing temperature and then use another technique called trending over time to be able to see how is that changing over time. These images don't show numbers, but you can put markers on there and you can trend the measurements to maybe schedule maintenance efforts accordingly, or find out, why is that bearing hot? This is a screening approach. You don't know why it's hot. You might need to use another technology to determine, is this literally a vibration issue? Is it a lack of lubing? But thermography points out that something is trending the wrong way. Comparative testing is it's a nice way to, without a lot of work or gathering a lot of images, be able to compare assets that are all operating under the same conditions at the same time. You can look at them and see that if this is 2 different assets, well, on this one, it looks like the bearings are hot. Again, and the coupling's a little bit warm too. You can look at that and say, well, I don't know why it's hot, but, out of these 10 motors that are driving pumps, it's nice to know that this one's hot. I'm going to focus efforts on this one and then do a deeper dive, perhaps diagnostic. So that's really the approach. And thermography we're not going to focus on any other applications, but wide variety of applications for thermography as it relates to minimizing downtime. And of course, we always advocate inspecting safely. So if you have high energy or medium voltage installations, switchgear, thermography is line of sight. We recommend that you install infrared inspection windows, which allow the infrared radiation to pass through, so you can perform inspections safely in those high energy environments. We'll take a look at a few different electrical measurements. Certainly all assets require adequate power. So power analyzers may be an essential tool for you to rule in or rule out power as a cause of downtime. Again, it's about cost savings. You want to minimize that downtime. So electrical power and power parameters. Some of the power analyzers on the market now, here's an example of one that can not only measure electrical power, but through the electrical connection can derive speed and torque, which lets you calculate mechanical horsepower and then mechanical efficiency. There's a lot of things on the mechanical side, or how you're operating those motors, that can shorten the length of the life of motor. Heat's one of the main enemies. Well, from a dashboard approach on the tool, you can see that if you are operating up in maybe a red condition, that might be an overloaded condition. That's going to shorten the life of your motor. So it'd be great to know if you are operating it in that condition. So some of the factors, overload, unbalance, harmonic distortion, those can all shorten the life of a motor, and having that power quality and motor analysis screening tool can, again, if used proactively, can help identify potential issues that you can then take a deeper dive and find out why. Why are we operating in overload or an unbalanced condition? VFDs are at the heart of many of your assets in a plant. And there's always been a challenge in, how do I know if I have a problem with the VFD, or is it the drivetrain, or is it my incoming power? A new class of tool called a motor drive analyzer helps automate that process and make that quick and easy. It provides a guided user interface, starting from, where do I measure? Motor input, DC bus, drive output, motor input. What are the pertinent health measurements? They're all listed in a menu. So when a user picks a particular measurement, the tool will show you how to connect it up, where to connect the probes. It'll automatically set itself up to make the measurements, the right measurements. And then you have the ability, if you want to save those measurements in a report. This can be very useful for, again, baselining new equipment, or looking to see what good looks like, and then if you have an issue, or on a proactive basis, comparing today's measurements with what good looks like to identify potential failures. Again, lowering costs, minimizing that downtime. Insulation resistance testing, another great way to troubleshoot motors that are overheating, tripping breakers, but you can use it proactively as well to trend insulation resistance over time. Once that starts to drop off, that might be a trigger to you not to wait for downtime, but to schedule maintenance, rewind, replacement, whatever that might be. So you can save and trend those readings as well. Let's take more of a look at vibration screening and diagnosing. We'll look at a couple of route-based tools. So handheld tools you would take out into a plant and walk a route and make measurements. We have a screening tool, kind of think back to that healthcare analogy. The vibration meter is similar in function to a nurse. Makes intelligent measurements, looking for bearing health, looking for overall vibration, and then comparing that to known levels of acceptability to be able to make that quick call. Is this good or not good? So it's a great screening tool. Again, narrowing down from all of your assets to the ones that can be the bad actors. Measurements can be saved, again, trended with Fluke Connect. On those assets where you find issues, it might be worthwhile to have the doctor visit. So there is a vibration tester, which is more of a drivetrain tester, that not only will tell you you have bearing issues, however, you have that because, for example, as a result of misalignment. So it's more diagnostic, getting to root cause to symptoms. And you can actually trend those faults over time. For assets that are difficult to reach or unsafe to reach, we have sensors, vibration sensors, which can be mounted at varying locations on equipment that will transmit their readings and also give you that same good, satisfactory, unsatisfactory, unacceptable alarm flags. This might be used in hard to reach spaces where it's difficult to make measurements with a handheld tool, or unsafe environments. And then again, kind of referring back to laser shaft alignment as being a potential corrective action. If you find that alignment is an issue and you don't have a formal program, these tools are also guided, very straightforward, easy to use, and even pretty prescriptive in what you need to do. In this case, we have a vertical misalignment. You need to add shims. So many mils under the front feet, so many mils under the back feet. So they can help to, again, correct for problems, lengthen the life of equipment, and minimize downtime. We had mentioned Fluke Connect is really a software platform for Fluke for wirelessly connected tools, either handheld or more mounted tools that stream data, condition monitoring type of tools, back to a cloud. Those measurements can be associated with assets if you so desire, that can be looked at over time from anywhere in the Fluke Connect environment. A little bit deeper look at that. There may be some condition monitoring type of tools, such as the vibration sensors, streaming data on assets with alarms into the cloud. Here's an example of the 3 different types of route-based thermal, vibration, electrical measurements. All can be fed into the Fluke cloud, assigned to assets. You can generate work orders if you want to, or if you don't need to start that big, then just literally use the handheld tools and just take corrective actions based off of that. The platform allows you to grow as you need to grow, but doesn't force you to have to create a full CMMS system. So bottom line, it pays to be proactive. All the methods that we looked at, downtime, maintenance cost savings, lengthening the life of equipment. The best approach, we think, is to make the most of what you have. Use a tiered approach. Think screening, infrared, vibration. Identify those bad actors, then take a deeper dive on just those rather than analyzing everything. So start small, save data, save health measurements, match technologies and tools to your expected failure modes. So you have experience, you know how things fail. So match that, and then save the data along the way, document cost avoidance, grow your program as you have more success. So we're going to look at the next aspect of cost savings, namely energy savings, and introduce an exciting new technology called acoustic imaging. But first, let's take a look at, well, how can we save energy? Well, it's really through leak management on compressed air systems. In the US, the Department of Energy has done studies and shows that a typical plant that doesn't have a leak detection and repair program loses anywhere from about 20 to 30% of the compressed air capacity due to leaks. So to make this a little more real, let's say you have 200 horsepower total of compressors. They're operating nonstop year-round. Your base rate to run those things electrically is 8 cents a kilowatt hour. It's going to cost you around $90,000 to run those, and you're wasting about 26K of energy annually, based on that, the Department of Energy figures. So it pays to try and minimize that. Also, the DOE has shown that by being proactive, implementing a program, you can get that down to less than 10%. So you can save maybe up to about 20% of those annual energy costs every year. There's also other positive byproducts of leak inspection, which you may have production-related issue if you don't have adequate pressure or point of use. If your compressors are running more, cycling more, then it's also going to shorten the lives on that equipment. So there's a lot of benefit. They're recurrent and they're expensive. So it makes sense to have a proactive inspection program. So now let's take a quick look at acoustic imaging. What is that? It applies to leak detection. So This is a video on the Fluke website, and we found that our audio doesn't work that great in this platform with embedded videos. So if you'll indulge me, I'm going to play the part of narrator here and narrate our video. We count on air for a lot of important things. Compressed air is everywhere. We don't always think of the pain leaks cause. Leaks can stop us in our tracks. What could you repair if you had an easy way to pinpoint a leak, even from a distance, and save money? If you rely on compressed air, you can now forget about the old, slow, and possibly messy way of leak detection. The new Fluke acoustic imagers use patented sound sight technology to visualize leaks. Enhanced scans can clearly see leaks you can't even hear. The Fluke II900 and II910 acoustic imagers work in noisy environments without needing to shut down the line. Scan large areas quickly so you can find leaks much faster and improve your bottom line. So what really is acoustic imaging? Really, it represents what we believe is a better way of detecting leaks. The traditional way, and it's a good technology, is ultrasonic measurements. Any type of compressed gas escaping through an orifice will emit noise up in the ultrasonic range. And traditional tools can be used to detect that and then to not just detect, but eventually locate where the leaks are to effect repairs. So acoustic imaging is a different way of implementing ultrasonic technology. So the idea is that through ultrasonic measurements, it's creating a sound map or an image that is overlaid on a camera display to not just detect the leak, but to easily visually locate the leak. So it's used for leak detection on a variety of systems, compressed air, but also other gases or vacuum leaks, steam leaks. So there's a wide variety of leak applications that it could be used on. One of the benefits of making leaks visual versus traditional methods are anybody can visualize a leak. You're looking at a hot spot, we can say, okay, well, this detects leaks. That's probably a leak right there, right out of the box. No difficult training, no experience needed. And because it's visual, you can see things or detect things at a great distance and then move in closer to be able to pinpoint the actual source. But a big benefit is being able to do that when a plant is running. A lot of people will wait for shutdowns and they'll send people around listening, with their ears and maybe even with soap and water to find leaks. So it has a lot of benefits in terms of time savings and ease of use. We'll illustrate that on how it does that versus conventional ultrasonic tools. This would be an example of a conventional tool, handheld tool. Again, it's ultrasonic. The technology works well. Somebody will be walking around with a handheld tool with either a wand or perhaps a parabolic antenna to pick up ultrasonic noise. The tool then will translate that down into audible noise that a trained operator can hear. And I mentioned a trained operator because they have to interpret, is that sound actually a leak or is that something else emitting some ultrasonic noise? So you need a trained ear, if you will. So it requires experience, expertise, training on use of the tool and interpretation of what you are hearing. So it's a listening tool, but the user needs to interpret also by listening. It also requires that you go point by point. So you need to move up very close to all of the fittings, hoses, quick connects, and there may be some challenges with that. Not only that, but we found that because Ultrasonic information, like sound, when it's emitted, it goes in all directions, and it bounces off of surfaces. So how do you know whether it's an actual leak source or whether it's reflection? So a lot of time spent in performing this activity, and it also requires experience and training. With acoustic imaging, rather than relying on hearing or interpretation of the user, we're making the leaks visible. So you can, rather than having to move up and go inspect every fitting, fitting by fitting, you can start scanning large areas. And if you detect something, as is evidenced here, you know that you have a leak. It could be a reflection, but you know there's something in that area. And then over here, you move closer once you see something, and then you can see and you can save it. There's also a simple tip to distinguish between leaks and reflections. You can actually just change your physical perspective to the leak while keeping the apparent leak on the camera display. Physically move to the left or the right. If the leak stays in the same spot, it's a leak. If it actually moves with you, it's a reflection. So just armed with a few user tips on the camera, you can be up and finding multiple leaks within minutes, as opposed to needing a lot of experience to find maybe one leak in 20 minutes or more. And then, being a newer tool, it gives you the ability to save, document what you're seeing, document leaks for either reporting or to issue a work or a repair order. So how are we doing that? As I mentioned, it's ultrasonic. This is the tool. We're seeing both the camera display side, operator side, and the measurement side. This is a bank or an array of sensors that pick up ultrasonic, specially arranged. And as sound is emitted, it strikes the microphones, and through processing and measuring slight time differences in when the sound arrives at each of the individual microphones, it's actually able to not just detect, detection's important, but location, to locate that leak. Where is it? It's able to place that sound map on the screen. That's where the time savings comes in. You don't have to interpret it. It's very definitive. Taking a look at a few example images in a variety of environments. Again, this technology works great, even in noisy environments. If you look over on the side here, on the side you can see frequencies, and this is a noise level or a dB level. You can see in this area, this exhaust leak, extremely noisy down in the audible range. But if you see the yellow box here, this effectively can ignore all of that noise here and only map leaks, as evidenced here on the display, up in the ultrasonic range if you want. And it's a touchscreen tool. You don't have to know how to adjust frequencies very intuitively. You put your finger on the box, move it up, move it down to best visualize the leaks. So very straightforward, very easy to use, and very impactful. Here's a nice one showing traditional tools, you'd have to get up close to that. So maybe a man lift, a ladder, fall protection, a lot of time, and maybe a little bit of risk. Here you can detect from many, many feet away safely from the ground and determine a leak source. It's a lot of benefits. Not just air, but a whole variety of gases. Welding gases, nitrogen, argon. Here's a few cases of at a steel mill, furnace gas, hydrogen, CO2, which we see, of course, in a lot of different plants, food and beverage, bottling plants. These are gases. Many of these gases you have to pay for. Some of them you have to pay a lot. So not only is it energy savings, any gas that's leaking here, that's money essentially evaporating into the atmosphere. So a lot of benefits for detecting leaks, and the technology is relatively gas independent. The same technology, just to let you know, can also detect other ultrasonic information up in even higher frequencies than typical leak emission. Utilities, electrical utilities, or substations, or larger customers that have their own substations and possibly medium voltage gear, there's an electrical phenomena called partial discharge, which you can think of as a partial arcing internally to inside of components that eventually can cause breakdown and lead to a failure, a catastrophic failure, perhaps an arc flash. So there's a lot of benefit in being able to detect those types of events, again, as that early warning system. Here's a couple of different examples. One of the tools that we have, the II910, in addition to being great at leak detection, it also gives you the ability to detect that partial discharge in medium voltage installations, substations, or again, at electrical utilities. Just to make it a little bit more real, here's an actual cost savings with a customer that they were a novice really with the acoustic imagers, and they had 4 compressors on site, and what they did was they actually used a Fluke power logger to monitor the energy consumption from their compressors. So they did a before study, performed leak inspection, repaired leaks, and then did an after. So you can kind of see what that looks like before, modeled a little more visually. So each of the compressors kind of shows energy consumption over time. If you look at how much they're drawing, when they're running, you can get a feel for the different compressors there. Of note, look at compressor number 4. That one, it looks like, and that may have been their backup as needed compressor. It looks like it's running pretty much all the time. After performing the leak inspection activity of the acoustic imagers, and then looking at the after, you can see from this graph down below that backup compressor is hardly used at all. So the actual numbers show that, if they were using about over the course of a week, 33,000 kilowatt hours, they were able to reduce that to under 25,000. So around 8,500 kilowatt hours saved just by fixing leaks. So if you annualize that, or they show that they recovered over 25% capacity, that 4th compressor is sitting idle now, and that represents about a 48 plus K savings. So big benefits. So we've looked at air and gas leak inspections save money, both in terms of energy costs or even wasted gas costs. Ultrasonic's a good technology for detecting leaks, but traditional tools require a lot of expertise and a lot of time. Acoustic imaging handles that by visualizing leaks. So it's not just detecting, but it's detecting and locating. That locating is key in being able to do it very quickly. It's easy, doesn't require any real training, just armed with some user tips, some guidance. Anybody can be finding leaks within minutes. So it's easy, and it saves a lot of time in a very worthwhile activity. You can document in the tool. The tool can actually even prioritize leaks, which ones are worse. So if you have 100 leaks, you may not have time to get to them all when you want to, but it'd be nice to know the 20 leaks that are causing 80% of the loss. So the tool can help prioritize leak repairs for you as well. Well, Sean, I think we're up to the point where we're ready to take some of the questions that may have come in up to this point.
Perfect. Yeah, thanks so much, Dave. So everyone, it's time for you to take advantage of having an expert like Dave here with us to answer any and all questions you may have. So to send in a question, just please use the chat feature. And please note that if you have any product-specific related questions, such as pricing or availability, we encourage you to visit our website, globaltestsupply.com. There you're going to find a list of our products, pricing, available technical specifications, availability, as well as our contact info and all the different ways that you can connect with our technical support staff. We'll be happy to address any and all questions that you may have. Okay, so looking at the questions right now, first question from Mike. First, Mike, thank you for attending. And no problem at all. We will send you the full slides with, we'll have the recording of the webinar, so all that info. And yeah, you'll have all our contact info should you have any questions about the equipment and want to reach out. Next question here is regarding with the vibration screening. So with the vibration tester, how do we know if the readings are good or bad?
Okay, I'm not sure if that's with the vibration tester or the vibration meter. I can address both. And if somebody, whoever asked the question, can clarify, we can go that direction too. But both types of tools, both the vibration meter, the screening tool, as well as the diagnostic tool, has intelligence built into them. Even the screening tool, if you're trying to narrow down from a lot of assets to which ones are having vibration related issues, built into the tool are measurements. Two in particular. One is a bearing health assessment or measurement that will actually call out on the screen when you make the measurement, which takes about 2 seconds, whether the measurement from a bearing health perspective is good, satisfactory, unsatisfactory, or unacceptable. So you get that immediate feedback on bearings. It also makes an overall vibration measurement. And built into the tool itself is actually a list of machine categories or machine types, and with each of them are that same, we'll call it green, yellow, orange, red scale as far as what the measurement represents, the overall vibration measurement. So you can pick the appropriate machine category, and it could be gearboxes, motors, centrifugal pumps, 37 different basic machine types, fans, a wide variety, compressors. So you pick one of the categories, and when you make that 2-second measurement, it's also going to tell you that overall vibration measurement. Is this good or not good? Again, helping really focus and direct your maintenance efforts. And of course, the diagnostic tool gives you that same 4-color scale. Actually, it is in colors on the tester, and it can tell you the severity level of the particular symptom or fault that's going on, as well as the underlying root cause.
Okay, yeah, interesting. It sounds pretty automated, the meters. And another related question that we just got from Vic is, are there any electrical tools to detect bearing wear from electrical current and voltage measurements? So that's
Yeah,
I'm not sure.
Yeah, great question. Great question. And there are some electrical phenomena that can cause bearing wear. One of which is we'll call it shaft voltage, or it's a phenomena of VFD driven drivetrains, where you could actually have some flashover occurring because of the pulse width modulated signal that's applied to the motor. You can actually end up having some high shaft voltages if you actually measure from the motor shaft to ground. And what happens is, of course, if you have a voltage, current's gonna try to flow. So you actually have, through the bearings, from the shaft through the bearings to the motor frame to ground, you have all these discharges that are happening at a very fast rate. And it can actually cause fluting in the races of bearings. So that's an electrical phenomena causing a bearing issue. And in that case, that might be an example of a screening tool saying that your bearings are bad. But if it's a VFD application, then perhaps the motor drive analyzer could be used to actually rule in or rule out that type of, that being the phenomena at play. So it does have a measurement in the menu of the tool that lets you see if that's what's going on. Hopefully that's what you were going for, or if not, yeah, please add something to the chat box, and we'll try and address it.
Perfect. Yeah, Vic, I'd love to, if you email us to talk more about this, I'm sure we can get more in depth as well.
Oh, absolutely. Yeah, definitely.
I think
We can talk
and the product, Dave, I think you hit the nail on the head from what I'm understanding. The MVA 550 seems like it might be the one to go at. Anyway, yeah, Vic, feel free to reach out to us regarding this, and we'll be happy to continue there. Jeff, you're asking about, will Fluke be conducting any demonstration seminars that give participants an opportunity to test the equipment? Dave, before you go, I just want to say, Jeff, we do have like a rental department, and it all depends on the product as well. So we can get you in touch with a demonstration opportunity or a rental opportunity, but it would depend on the product, at least from what I know. Dave, is there anything you know about for that?
No, actually, I was going to defer that one to you. So,
Okay.
that's something, because you are closest to customers. But what this might look like is, let's say it's rental situation. Certainly something that Sean, you'd be able to help the customer with. But if it is an on-site demonstration, then I would work with Global Test Supply. They will work with the local Fluke territory sales manager that works in the field, that would actually, on Global Test Supply's behalf, be able to go on site. So yeah, we really have it covered from both ways. So I would encourage you to reach out to Global Test if that's something, either way, rental or on-site demonstration. I think that's something I'd encourage you to reach out on.
Thanks, Dave. Yeah, Jeff, that's kind of what I'm thinking. If we can narrow down what product or products you're looking at, that'll help us find you either solution. So yeah, feel free to send us an email, chat, or call us at our contact info on our website. Vic's following up about the bearing with the the voltage measurement. How about bearing wear from shaft acceleration as it rotates through 360 degrees?
Not sure I exactly understand the question. As bearings wear, they do go through stages and patterns of wear. So with the without getting into too much depth, the Fluke A10, the vibration tester, is actually looking at and can determine what is going on with bearings as they start to get more into mid and late stage wear. They may start to bounce around in the races more. They start to wear. They may get pitted. A phenomena called looseness will start to show up. So if you see a diagnostic call of mechanical looseness as well as bearing wear, you know that you're getting into more mid-stage, late stage. They start to exhibit different patterns. You'll start to see different frequencies of vibration show up, based on impacting in the races. So that would not be really a screening call. The screening call could tell you that you have bearing issues, but the diagnostic approach would more tell you, well, is this actual mechanical looseness that's going on, or is it something else? So actually, if you found the problem that I described earlier, via vibration diagnosis, an electrical phenomena can cause, bearing wear and that mechanical looseness. So they would manifest themselves the same way, I guess is what I'm trying to say.
Perfect. No, that's great. And Vic, I think this is the kind of question where we could get even deeper with it. So
Sure.
don't
Absolutely.
email us. I'll work with Dave on getting an answer with you, and we can figure out more what your application is. All right, everyone. So unfortunately, we are out of time with the questions, but feel free to send us an email. On behalf of Global Test Supply University, we thank you for attending our webinar today. We hope you found it informative and helpful. Global Test Supply is available to assist you in any way. Simply visit us at globaltestsupply.com for anything you need. Through globaltestsupply.com, you will have access to our entire list of Fluke products with the descriptions and specifications. You will also find our contact info in order to contact and connect with one of our technical support staff who are able to answer any and all of your questions that you may have. At the end of this webinar, we will have a very short survey that we'd like you to complete, because your feedback will assist us in improving and allowing us to bring you more topics that are of interest to you. We have some upcoming webinars in the next few weeks and months, so please visit the training section on globaltestsupply.com for the full schedule of upcoming webinars and topics. Also, last thing is, don't forget that as a thank you for attending our webinar today, your name will be entered in a draw to win $100 for your next online order. The winner will be announced on our social media channels, so please be sure to check us out there. Dave, thank you so much. That was very informative. I know I myself learned a lot, and I'm sure everyone else did. We really appreciate the time you took today.
Appreciate it, Sean. Thank you. And thanks everybody for attending.
Yeah, thank you, everyone. You have a great day. Take care.